Hello to all of you, and thanks for joining me today. Just before to kick off the presentation, let's wait a couple of minutes more to allow other people attending different sessions to join us. So please bear with me for a couple of minutes still. Meanwhile, just a reminder, if you have any question, please write them into the chat. If I won't be able to address them online, definitely I will reply to you offline after a couple of days. So please write them all. I think we are ready to go. So let's start. So a good morning, good afternoon, and good evening to everybody. And thanks, Linaro, for having me at this event today. My name is Luca D'Ambrogio. I'm a chief analyst at World Intelligence. And today I will give you an overview of the disruption and the innovation that software and hardware architecture are having in the automotive industry. This is the outline of my deck. I will update you briefly about the status of the market, also considering the shortage of semiconductors impacting the supply. Then I'll go really quickly through the complex and much broader automotive ecosystem that is affecting the industry. I will deep dive into more details about the new automotive architecture, the role of software, and also the further hardware consolidation that is occurring. I will briefly touch the topic standardization and the usage of open platform. And I will go also through the revolution in terms of profit pool and business model that the industry is expected to have. At the end, I will summarize with also some of the challenges that are ahead of us. So, is the latest figure from LMC and World Intelligence about the worldwide vehicle production. As you can see, there is a clear dip in 2020 due to the COVID consequences, but also 2021, as you can see, didn't recover back to the pre-COVID levels. In particular, we expect that there are about 4 million missing, and this is mainly due to shortage of the microchip in the automotive industry. And this seems to be confirmed by looking at the sales in the same period. We are expecting that by the end of the year, we will reach almost 86 million sales, so far above the vehicle produced. That means that production volume are coming from the rapidly decreasing inventory. And the decreasing of the inventory is happening from the beginning of the year till now. But let's not focus on these criticalities so far. So we see already the light at the end of the tunnel. So we are expecting that by the end of Q3 and the end of Q4, so in Q4, there will be more regular operation in the automotive supply chain. And in any case, this will have a minimal impact, in our opinion, on the key strategy, whether it's electrification, autonomous driving and autonomy, and the new mobility ecosystem that is the major activity for OEMs and tier ones. This is representing in a picture, let's say, the traditional perspective when thinking about the automotive. So it's the vehicle. In particular, our point of view is focused on vehicle features and application, whether it's nice and safe autonomous driving function, assistance function, or HMI and infotainment that are really helping and increasing the user experience in the car. In reality, the point of view of future mobility is quite different. It's a much broader ecosystem that is ultra connected by performing even low latency technologies. In particular, I'm referring to cloud and data center, where all the data, our software and server will be stored and delivered. And also the OEM backend and the concept of smart mobility in general, whether it's smart city, smart home, or even in an ITS system. And these domains are seamlessly interconnected and are essentially even not just for the future life cycle of the vehicle that is running today, but also for the future vehicle development. So the trends toward a software-defined vehicle and to centralized hardware are clear and come from the needs to adjust the automotive industry with several new features and applications, and the requirement for cloud-connected cars, basically. Electronic control units are migrating from deeply embedded system that you see on the left to more nomadic function delivered by high-performance computer or servers, if you like. Software will drive the server architecture and the migration for even highly embedded systems. So as we can see, the two worlds. In the past, also the requirements are totally different. So for a highly embedded system where the hardware was the star, efficiency, safety, and security was the major requirement. Today, the key requirements are flexibility, performance, and the possibility to have update and upgrade of the system along the lifetime. Another key element is that the hardware was distributed, now is centralized. And from the software perspective, today we have, even today, still a piece of software that has maybe tens or 100 million lines of code that is pretty complex to develop, but also to maintain and qualify or certify for safety critical application. Vice versa, we are moving toward a software-oriented type of architecture, modularized software, where instead to have one piece of software with 100 million lines, we'd rather have 100 million pieces of software, but with one code each. So this is clearly an extreme case. It's not the reality, but it's just to tell you the complete different mindset in approaching the software in the HPC era. The last important point that I would like to highlight is that in the highly embedded system, the application was ECU defined. So the ECU was defined by itself with the application having inside the ECU itself all the software requirement, all the hardware was inside the ECU, was self-contained. Today, this is not the case, and I will show you more what I mean. So where in the past, the hardware was the star. Today, the software is the black hole that sucks in basically everything. So looking at the hardware topology, today, the status of the art is an architecture with domain controllers. This brought in already quite a bit of consolidation in ECU number and reduction of complexity. But the next generation will centralize even further the hardware into HPC service and gateway type of control units. So this is just an example, as you see here, 2 HPC and 7 gateways. So different OEM might have slightly different topology. We are expecting a number of gateway, for example, between 4 and 6. And so far, we are expecting as well the number of central computing that might vary between 1 and 3. But the target is clear. So by 2025, there is an expectation of the reduction, or a significant reduction of electronic control unit down to one half of one third. So from 70, 80, go down in the 30s type of number. From the hardware architecture, consolidation is clear and HPC are on the way. On the software, as I mentioned already before, service-oriented architecture represents a significant change in the approach, derived from the IT industry, like the microservices that we see in the cloud. OEM at the end will have probably 2 stores available, one hardware store and a software store like you have in your smartphone. And based on the vehicle spec, hardware and software module, whether premium hardware, middle range, or economy, for the different lineup of a vehicle, or the software. So you will have different operating system, real-time or not, middleware, basic service, or even application, will be mapped into specific hardware. In this specific case, high-performance computer, central servers, or physical gateway that we said are the zonal gateway, and will be mapped to virtual, to create virtual ECU. So if in the past we were having a self-containing, instrument cluster, you could keep in your hand an instrument cluster. All the hardware and software was inside the instrument cluster. Even simulation and R&D could have been done separated from the rest of the vehicle. Today, this is not more the case. You might have an instrument cluster virtual ECU, but physically, the driver will see just the display. Behind the display, there is nothing in terms of hardware, in terms of software. All will be centralized in the HPC or eventually in another central computer. The discriminant whether to centralize function in the HPC or not, or maintain the legacy like old ECU, is if the OEMs would like to have this application, this ECU, this module, updatable and upgradable in the lifetime? If the answer is yes, those will be centralized in the HPC in software function and then virtualized in terms of ECU. So what does it mean at the end in vehicle server and HPC? With this slide, I want to go a bit deeper in the structure of the hardware and the basic software. Today, hardware and the SoC that are available allow much higher performance and are able to run even multiple OS. And this is extremely important because the car is a complex system that has different application running, with different performance, latency, efficiency, flexibility, security, quality, and safety requirements. So you might need to have to choose a specific operating system for each one of these requirements. So you might have infotainment system where you want to run adequate operating system like Linux or Android. You might have ADAS, and you might have X-by-wire. So each one might have an optimizer operating system like Android, AUTOSAR Classic for safety critical application, or maybe for autonomous vehicle, new middleware like AUTOSAR Adaptive or else. So all running managed by the hypervisor or a single potential on a single SoC. So what is required here is to manage this complexity and the middleware, especially for autonomous vehicle. We need to have possibly an open platform, software open platform, and a standardization that handle it. The problem is talking about standardization is when you have more standard to cover a simple topic. That is, in this case, the middleware. And this slide wants to tell exactly this. So if you talk about standard, but you have multiple standard, that is a sort of oxymoron. So you cannot take advantage and benefit of the standardization. And this is what I want to show you. What it seems to be a sort of regionalization. So going back to regionalization from the globalization time that we are part of, at least today. So it seems that China and rest of the world, or rest of the world and China are having some friction. So at least that is my perception. AUTOSAR, for example, is, as you can see from the logos here, is full of Western country companies, so American and European, while AutoSAM has been created in parallel somehow of AUTOSAR to cover the same middleware for autonomous vehicle, for example, and vehicle in general, and is mainly a supply chain that is all Chinese. So even the Chinese vendors like or supplier OEM in the AUTOSAR like Baidu or Geely that are part there, or Great Wall, their function there is more a supporting member. They are not really active. So this dichotomy is pretty interesting because China needs and wants to have a strategic role in the software IP. And they want to also reduce costs and have a local support that today probably AUTOSAR is not giving properly because all the suppliers are coming from Europe. And the Chinese path, it looks to be clear. So they seems to have based their platform on AUTOSAR. Although I noticed already that, for example, the API support is not compliant with AUTOSAR. So I know that they are talking, and I hope for the claimant compatibility will be compatibility at the end for the benefit of the entire industry. There are not just AUTOSAR and AUTOSAM, but there are other organizations like CVII with Geneva and TWC or ASIMI.eu that are trying to tackle the same standardization process for a key element like the software and the middleware in the future of the car. This slide reflects a bit in practice what I have been talking about in the last minutes. And it's already in production. So we are talking about the MEB platform with the ID3 and lately with the ID4 of Volkswagen. And basically, Volkswagen implemented the centralization with HPC, like ICAS 1, 2, and 3. The ICAS 2 is not yet there. Is the autonomous vehicle high-performance computer. There is the ICAP 1, where there are all the body vehicle functions, and the infotainment part, that is the ICAS 3. But even here, also Volkswagen implemented AUTOSAR Adaptive with a middleware standardized with hypervisor and multi-operating system. And as well, they are providing IP packaging type of connectivity in order to address each and every single ECU that are available in the car in order to update or increase the relevance with an upgrade in case of necessity. So clearly Volkswagen is not the only one, it's not even the first. So if you're looking at even at Tesla, as disruptor, they are there already with even zonal implementation of HPC with the front, rear, and left and right domain controller, or HPC. What is important for me and why I like Volkswagen is that Volkswagen is a mass market OEM, one of the leaders worldwide, and represent the legacy, the traditional OEM. And they are showing to embrace totally the revolution that is affecting the mobility ecosystem. So let's talk about what is outside the car. So connectivity, as I mentioned, and in particular IP-based protocol is essential once again to share software and data, bi-directional, I mean, going from the car for update or even feedback some data important that can be analyzed and provide added value for OEM and tiers. This is a scenario represented by the picture that many OEM are looking to implement. Very secure communication via firewall between infrastructure, public cloud, and OEM backend and the vehicle. And as you can see, there are a lot of possibility to extract value and profit there. So with real-time data analytics, with development, improve the development, maintenance, services, and upgrade and update, or even execute directly code from the backend. And the connectivity is not important just to, once again, and I stress this point, to upgrade and update the vehicle during the lifetime. The bidirectionality of the connectivity allow even at the end to improve the manufacture, improve the diagnostic system at the OEM premises that can take advantage and reduce significant the cost thanks to digitalization. So vehicle, as I mentioned before, are software defined. And data, though, is the one that I believe will drive the business. So data will offer a huge amount of possibility of revenue stream and new open, let's say, open new profit pool to even increase the margin, if not increase the revenue. So as you can see from here, there are a lot of data types that are available from the automotive industry, from driving style, location, sensor, terrain, health information about the driver, the passengers. But we have also different data usage models. So we have advertisement, marketing, CRM, dealer services, and we have even different users that might use differently the data and that we provide or the car provide to them. So we will have OEM, we will have municipality, we will have dealers, driver, and telco. So the permutation of these bubbles here will allow an infinite number of business case that you can monetize the data opportunely. So the important is that you create the competence in terms of data analysis and software like AI, but also provide an infrastructure in terms of storage and performance and processing data performance like a data center, where you will be able to collect, clean, format this data, and at the end create the value and extract the value out of that. This is an example of the value. So there are three major areas where we can develop value from data. So the typical B2C or B2B2C, where the OEM might sell the product, the feature, the upgrade to customer, or even subscription fee services. There is the B2B, where data can be sold to third party to tailored advertisement or even a product recommendation for passengers and driver. But there is another important aspect that is a huge opportunity of digitalization in the automotive industry is cost reduction. So you get your profit higher because you get higher revenue, but also because you get the lower cost. And this can be done by improving insurance and warranty. So if you are ensured that you can predict even the failure of your car during its lifetime, you can do predictive maintenance, you can adjust diagnostic and feedback the R&D even for optimization for the next generation of the vehicle, reduce the cost of repair, optimize the fleet operation, etc. There are a lot of possibility even here. And the last last but not least, is less visible in terms of monetization, but it's extremely important. It's brand differentiation and added value of the brand. So you might increase the value of your brand by a loyalty programs with CRM, improving your features and put your brand in terms of quality of service, in terms of security, in terms of safety, or even in terms of HMI user experience. I would like to touch briefly before to leave you this other aspect. So it's the raising importance of vehicle simulation and model-based system engineer. This is essential at various levels, from vehicle to infrastructure. And this is necessary to evaluate a complex system based on a model in the development at time zero, because we are moving now from the physical ECU to virtual ECU. There are different services that can be here attached. You can service the typical software for simulation software, but you can provide as a service software together with the platform that is able to simulate the entire vehicle or the entire electrification portion or entire the autonomous vehicle portion. And this is able to ensure the coverage of all possible corner cases at an acceptable amount of time. On top of that, you can add even the third part, that is simulate the vehicle inside the manufacturer of the R&D with the help of digitalization, again, the help of the digital twin. So this model-based system engineering is extremely important, because also the workflow in terms of working together between various players in when creating the new model is completely changed. There must be a much higher synchronization that start really early in the development phase. And this type of tool are really essential. So let me conclude with this slide. So again, automotive has a bright future, but there are a few clouds that needs to be resolved or take advantage of. Exactly, it's an opportunity as well. So important again is that there is an extremely expanded ecosystem in the automotive today, and you need to provide this ecosystem, robust ecosystem, when you sell your product to your customer. So partner, collaborators that are all geared up together with your company. You need to also invest more in advanced skills, especially when we are talking about software that is driving your car and data that is driving your business. So new business model and profit pool are available to you, but you need to take care and be prepared and competent in take advantage of this. Important is also operating process that changing, and also the mindset. And this is very important. And you see a lot of organizational change, like company like Bosch, that are completely disrupting their traditional operating processes. They are disrupting the silos type of thinking, where you were having the powertrain business unit, the ADAS business unit, infotainment business unit. This doesn't make sense anymore. For what I was saying before, the ECU is not something that you can keep in your hand. It's something that is nomadic. You don't know where your software and your hardware for the specific application where ADAS infotainment will be. So this requires a new development workflow, extremely high synchronization along the supply chain at really early in time, I would say at time zero when you design your car. And new tools will need to be available, and you need to be skilled also on that. Even because when you are talking about safety critical application, autonomous vehicle, you will need to have an entire vehicle in the loop. You need to have the hardware in the loop. You need to have the model in the loop, and as well, clearly the software in the loop to ensure that all the safety critical corners are covered. So with this, I would like to leave you. I don't know if you have a question. So please, if you have a question, write them in the chat. I don't know if you have time to answer them now, but I'm pretty sure that Linara and the organizer will send them to me, and I will provide you with my answer offline. For the time being, I thank you again, and goodbye. Talk to you soon. Ciao.